Okay, now shifting the y was easy, but shifting the x is a little bit more complicated to explain in terms of horizontal. It's not that difficult, but just to show you here how this would work. Um, a typical shifting here, and I'm going to just show you, is that if I have a function, let's call this function f of x again, and I'll just use the old x squared here, okay? Whatever I do to the x term now, not outside this function, but inside the function, will affect it. And so, if I do something like add 1 to each of these, now I'll just show you here, is what I'm going to do here is I'm going to use f of x plus 1 and just show you what happens to y. I'm going to leave this side right here and just show you. So I'm going to do f of x plus 1. Now we already know that this is going to shift it to the left, which is kind of counterintuitive. We're thinking, well, it's plus 1, it should go to the right. So what's going to happen here is if I do this, I'm going to get x plus 1 squared. Now I'm going to set this equal kind of to the new y here, and what's going to happen to this y here if I do that. Well, what's going to happen to it, if I follow along here, is I'm going to get, well, y is equal to x plus 1 squared. And so as I do this here, what's going to happen here is I'm going to move this around, and I'm going to get here, if I take the square root of both sides, I'll take the square root of this. Okay, and if I take the square root of this, I'm going to get plus or minus y is equal to x plus 1. Now you'll see what happens here is that x now is going to equal plus or minus y minus 1. I want to point out here that it's a minus 1. In other words, each x value will be this. Now before, when I had this original function, in fact, if I take the square root of both sides, I'm going to get plus or minus y is equal to x as well, without the shifting here. And so with the translation here, you can see that when I do it plus 1 inside, it actually results in a minus 1. In other words, every x value will be subtracting 1. So in other words, if this was my original function, xy, my new one is going to be x minus 1, comma, y. This would be every point. And so again, if this was 0, comma 0, my vertex, let's say, my new vertex here, when this is shifted, would be negative 1, comma 0, because again, it's going to be 0 minus 1. So that's how this works here in terms of just trying to look at how this shifting works. With the dilation, I can show you that as well. With the dilation, let's do that one here and just say, well, let's have y is equal to f of x. And we'll make it, let's make it, well, I'm going to have a translation here just so it's easier to see here. Actually, no, it's fine. I'll just say here that that's equal to, I'm going to make it 3 halves x, and all of this is going to be squared. And I'm putting this inside here so that it's inside and it's going to affect the x. I'll just show you what happens here. If I do this now, the exact same thing I did before, and I'm going to say, well, okay, let's square root both sides. Okay, and so my original function, just a reminder here, was xy, and that's because y was equal to x squared. Well, now here's my new one. Now, if I do my new one here and take the square root of both sides, I'm going to get plus or minus root of y, and that's going to equal 3 halves x. Now notice what's going to happen here. My next step here is going to be to get rid of this. In order to do that, I could multiply both sides by its reciprocal, in which case I'm going to get plus or minus 2/3 root y is equal to x. And again, it's because I divided both sides by 3 halves. And dividing by 3 halves will just result in a reciprocal. This is why when I tell you that if it's inside, the actual factor is going to be 2/3 of the original value, which again, just to remind you, was x is equal to plus or minus root y. Okay, well now it's 2/3 because again of this result here when it's from the inside. When it's outside, it directly affects it, but when it's inside, it's going to only affect this. And so every value here, okay, would be 2/3 of whatever this value was here, but the y would stay the same because it's only affecting. Of course, you're going to get functions that affect both the x and the y, and it depends on the complexity of it. But this is essentially how to deal with something like this. in a function that's affected horizontally.